RCHUB International Foundation for Research and Education, an ISO certified.
So there are various statistical tools to perform analysis. If you're going for good from alpha, or if you're going on with simple Excel, or their SPSS or AMOS or eViews, the thing is that you will be getting the same output. Output in the sense, the resultant table will have the same values. Whether whatever software you use, the resultant table will be same. So today I'm going to illustrate you various analysis, what I have explained to you yesterday, and I'm going to illustrate how to write an interpretation for those tables. So let me start with the very first beginning. So I told you, right, if there is categorical data and you are going to analyze that one particular categorical data, you can simply go for the percentage analysis. Let me share my screen. Let me share my entire screen. Is my entire screen visible? Is my entire screen visible? Okay, I hope my entire screen is visible. So this is the thing. So yesterday I taught you, I have explained you what this entire statistics all about. So I told that we are performing statistics only for these 5 reasons: to describe a data set using percentage analysis or descriptive statistics, or to find whether the variables are having significant association, or we are in order to identify whether there is significant relationship between a variable, or is there any significant difference in the variable, or there is significant influence of one variable or the another variable. So it is for these 5 reasons we are performing all sorts of statistics. So let me start from the very beginning. So the thing is that we have, and I hope you remember when I told what I told. That when it comes to statistics, there are only 2 types of data. Forget about the nominal, ordinal, the cardinal, the other things. There are only 2 types of data, that is categorical and metric. So based on this only, your entire statistics relies. So let me start with a very fundamental thing. So if you have only categorical data, you will be doing a descriptive statistics using percentage analysis. So that's what I'm going to perform here. So let me explain you. See, uh, so this is the question now. So this is the question. Actually, what he okay. So what was his study was about training need analysis in software industry. So he wanted to know how a software industry will understand there is a need for training or what. So it is for that he have framed a questionnaire and asked different segment of employees who were working in the software industry. So first, he asked about the demographic question, that is, what is his gender, what is his age, the marital status, education qualification, the total years of experience. So all these things he have asked. And now how the assessment of training need is been done. Are they aware about the training need awareness that by the HR? So it is for that they have asked a few questions. And to identify the performance gap, he have asked so many questions. So it goes on, organization analysis, and it goes on. So he have framed many questions with various factors. So, and the thing is that in order to analyze, so let me make use of this SPSS software today, because I tell you what, as I stated before, whether you are using SPSS or the Excel or the other software like PSPP, whatever software you use, the resultant table will be the same. It will be giving you the significance value, and it will be giving you the descriptive statistics and the percentage analysis, and it will be generating the graph. All are same. The thing is that you should be in a position to know what kind of analysis need to be done and how to interpret those analysis that has been performed by you. So that's what I'm going to explain you in today's session. The entire session today is completely deals with data analysis. So pay attention. So this might be management related study, but if you pay attention closely to the analysis and interpretation, what I'm performing right now and how I'm explaining you to write an interpretation, that goes on not just with the management, but also to the commerce, but also to the social science studies, but also to the even the technical students who are doing experimental study to know whether the test element 1 is better or test element 2 is better, which antenna efficiency is better. So whatever be your background, this interpretation may help you. So pay attention very closely. The thing is that in order to do a simple percentage analysis, let me briefly explain you what this SPSS software is all about. In this SPSS software is specifically designed to analyze questionnaire-based study. Questionnaire, not just questionnaire, but also secondary data also, but mostly questionnaire. The thing is that here in the label session, you see all the questions is being typed. You see the first question was gender, followed by age and marital status. You see, all this is being typed here. The gender, age, marital status, education, qualification, everything is been typed here. And its corresponding options, the corresponding options is been typed in the values. You see, it is typed in the values. So you see, the first option is male and second option is female. The 1 is male and 2 is female. That's what we have given in the SPSS. We have instructed that, see, this SPSS software does not understand string or alphabets. It only understands numbers. So I have told that if it is 1, understand it as a male. And if it is 2, understand as female. So that's what I'm giving. So similarly, I have entered all the options and I have typed whether what kind of data type it belongs to, whether it is categorical, that is nominal, or it's metric. Any Likert scale based question or the numbers is nothing but a metric. We can say it as scale. And I have typed all the question, all the options, and I have also entered the entire data set. I tell you how I entered this data set. As you, when it comes to this data set is being copy pasted from the Excel sheet after scrutinization. This Excel sheet plays a very, very important role if you are dealing with voluminous data. See, when you are using Excel sheet, you have a lot of option to scrutinize your data set to get more reliable data set. More reliable data set in the sense, you can avoid missing data respondents. You can even even avoid unengaged respondents. I tell you how. Say, for example, this is the data set. This is the data set. Here I have typed 1, which means the first respondent is a male respondent and he belongs to the age category of 1, which means after collecting the data through the questionnaire, he have ticked male, and he also have ticked he is belong to the age category of 20 to 25, which is the first option. So I have typed as 1 because as I told before, SPSS only understand number. It doesn't understand alphabets or words or strings. So, and the D3, he have in the demographic 3, the marital status, he have ticked as 2, that is unmarried. So all this is being numerically written. The respondents one's answer, the tick mark option is being numerically written. Similarly, the data collected from 463 respondents were numerically written, and then finally it has been scrutinized. I tell you how to scrutinize this using Excel sheet. Excel sheet is a beautiful tool and most powerful tool to scrutinize any data set that has been given. So you can use this option, that is like count blank. say for example, the first equal to count blank. So count blank, and I'm going to put this as a range. You see? So it is giving 0, which means there is 0 blank area. All the options is being ticked and all the data is being entered. And if it is 1 or 2, it is always advisable to remove those respondents who have not given those answers. And in case there is an option of like this, some respondents, if you give a questionnaire, even without reading the question, they will be simply typing as 4. That is agree, agree, agree. Disagree. So these kind of respondents is called as unengaged respondents. This also you can identify using the formula called as equal to standard deviation, say for example, standard deviation. And let me put from this value to this value. Okay. So it's 0.5. Instead, if all the values are 4, you see the value becomes 0. If any of the standard deviation is 0, we can say that those respondents are unengaged respondents, which means they have taken all the value as the same value. That is, if you have taken 4 for all the options. So by using various options like count blank, the standard deviation method, you can easily scrutinize your data set or scrutinize the data set and get a clear set of data set for your analysis. So that's the beauty of the Excel sheet. So it is always advisable to use Excel sheet to create a data set, scrutinize a data set, and finally put into the software for analysis. So this is the data I have entered into the SPSS, you see. This is the data I have entered into SPSS for analysis. Now, let me explain you different analysis using SPSS. So in order to perform a simple percentage analysis, what you have to do, let me do percentage analysis for these demographic questions. That is gender, age, marital status, education qualification, income level, and total years of experience, T6. So So I'm not here to explain about the SPSS and how the things. I'm just going to explain you how to interpret the tabulation or the resultant table that has been produced. So coming to the simple percentage analysis. When we talk about the simple percentage analysis, you have two important things to get discussed. One is the frequency and its equal percentage. So forget about this. Let me copy paste. And Excel sheet is a beautiful tool to even scrutinize the result. Say, for example, I don't want these values, these cumulative values, which is completely unnecessary. So gender, age, marital status, educational qualification. So these are the important data, right? So I don't want even these options so that my table may look clean and clear. So let me delete this. Now you see the table is clean and clear. Let me increase the font size so that everybody may be able to view it clearly. Okay, so we can simply say that with respect to the people working in the software industry, with respect to Chennai, majority of them, nearly 340 out of 462 respondents, 340, that is 73.6 were male. And 122, that is 26.4% were female. So you see how I have interpreted the frequency and percentage analysis. First, I have illustrated the biggest value, the highest value, followed by the lowest value, the next lowest value, and it goes on. So with respect to age category, majority of the respondents in software industry were found to be were between the age between 26 to 35, which was measured to be 185, that is 40%, followed by 20 to 25 years, that is equal to 146, which is equal to, in bracket, I will put it as 31.6. So in similar fashion, you have to write the interpretation for frequency and percentage analysis. So you have to start with the topest value, the highest value, and move on with the next following values. And most importantly, you have to mention the frequency value, and in bracket, you have to illustrate its equivalent percentage. Or you have to illustrate the percentage, and in bracket you have to illustrate the frequencies. So this is how you have to write an interpretation for the frequency or percentage analysis. So okay, now let's move on to the descriptive statistics. So descriptive statistics, let me open a new data set. Time for, yeah. So you see, this is a secondary data. So this is a secondary data. This is purely a secondary data. This is the data that is related to export import between the BRICS nation. BRICS nation in the sense Brazil, China, South Africa, and Russia with India. Okay, so they of agricultural products. So this is the values. I wanted to know how much of agricultural product is been exported to Russia in terms of rupees. So I have the data. So I for the past 10 years. So what I'm doing is that it is for this, I'm going to perform descriptive statistics. So I told you, right? When it is a categorical data, says like gender or age or income level or age, other categories, all are categorical data. For those categorical data, you have to perform, you see, for those categorical data, you have to perform a percentage analysis. But in case if the data is metric, it's purely number, then you have to go for the descriptive statistics. I told you, right? What is descriptive statistics? Is deal with mean, median, mode, the standard deviation, kurtosis, and weakness. So that's what I am going to do right now. So this is the data. So in order, let me perform a descriptive statistics. Descriptive statistics for export of Russia. I want, yeah, mean, standard deviation, or let me do by this. Mean, median, mode, maximum value, minimum value, range, standard deviation, skewness, kurtosis. Okay, let me click OK. So you see, now I got this output. Now I got this output. This is the output. Let me copy paste. Let me increase the font size. So you see, this is the value I have got. So whether you are using Excel sheet or whether you are using any software, you will be getting only these outputs. Okay. So now I got the output. I tell you what this value is all about. So mean in the sense, on an average, for the past 10 years, we have exported export agriculture product of worth 1,748.2360 crore rupees. Say, for example, you see this is the data set. So this is the data set for past 10 years. That is from 2024 to 14, 2014 to 2024. So this is the data. So on an average, if you take them closely, it starts from 1297, that is 1,297.13, and then comes 997.43, 1,045. But on an average, we have on an average, the mean value, on an average, we have exported to Russia of agriculture product worth 1,748.2360. And median is nothing but the middle value. What is the middle value? Middle value is nothing but the value that is being in the middle. I told you, right? Value that is in the middle. So you may ask me, the middle value is somewhere here. No. The fifth value should be considered as a middle value. No, it's not like that. I will tell you. If you take a close look at these values, let me, yeah. If you take a close, if you take a close look at these values, first I'm going to arrange this sort in A to Z, smallest. So if I take, if this is the first value, this is the second value, and it moves on. It has 10 values, which means there are 2 values in between. You see, 4 values below, 4 values below, and 4 values above, but 2 values in between, 2 values in between. So I have to take the average of these two things, average of these things. So equal to average of these two things. That is the middle value. You see, 1823, that is 1822.9350. The value is same, right? So let me put it in decimal. You see, the value is same. You see, the value is same. So this is median is nothing but the middle value, and mode is the most repeated value. But if you take a close look, there is no most repeated value. If there is none of the value is repeated, then it will take the first value as the most repeated value by default. And it will be giving a value A, which means there is no most repeated value. I have took the first value as the most repeated value. That is by default. Don't consider this. That's why they are given as an A. So then comes standard deviation. Standard deviation is the how far the value is getting deviated from the middle value. So middle value in the sense 17458. You see, let me do the average value. Sorry, yeah. Average of all these is nothing but the mean value. You see, both the values are same. So if you take the maximum value, the maximum value is 2622.26. And similarly, the lowest value is 997.43. So if you take a close look here, equal to this, this. So if you take a close look, it is somewhere, it is 750 to 874. But if you take a 95% confidence interval, it will be around 500, right? So it's somewhere around 500. So that is what is being written here, the standard deviation. Now the mean value, it is mostly getting deviated 571 value below or 571 value above. So this is what is called as the standard deviation. And skewness is, as I told, is the measure of flatness. If the skewness value is greater than 0.1, greater than 0.3, it is very flat. It is highly skewed. But here it is not so. The data are normally distributed. Similarly, kurtosis value should be between -1 to +1. So that should be the value. It is 0.8, which means the data are normally distributed. So this is how you have to make an interpretation. So we can say that if we are getting a metric data, you can say that we are exporting here. For this table, I'm taking the interpretation. On an average, we are for the past 10 years, India have exported 1,748.236 crore rupees worth agricultural product to Russia. And it has a median value during the fifth median value of 1,822.9350. And it was during the first year, 2014, it have exported the lowest value. The lowest value is recorded. And it was during the 2024, the highest value is been recorded. And the standard deviation for the from the mean value for the export of Russia is 571.866. So this is how you have to write the interpretation. You have to discuss, and the export values are normally distributed. If the value is above it is above 0.1 with respect to kurtosis and skewness, at that point of time, you have to say that the data are not normally distributed. As simple as this. So this is how you have to write the descriptive statistics. So I have explained to you how to write a percentage analysis and how to write a descriptive statistics. Now let's move on with how to perform a cross tabulation. So to perform a cross tabulation, now let's move on to the significant association test. I told you, right? If both the data are categorical in nature, if both the data are categorical in nature, at that point of time, you need to do significant association test using chi-square statistics. So in order to do that, now, let me close this data set. I don't want this data set. They will confuse you because it's completely secondary data. And if I'm going to teach with secondary data, it is better to teach you with e-views rather than SPSS. That will more confuse you. So let me put everything in a very simplistic manner as possible in today's session. So let me perform, with respect to gender, let me consider these two questions. How does your organization assess the effectiveness of the provided training? The options are verbal feedback received from the participant, from the trainer, and written feedback. So many options are there. This is once again a categorical data. And with respect to gender, this is also once again with respect to categorical data. So let me perform a chi-square test. So now we got the output. So when it comes to chi-square, you will be getting two outputs. One is the cross tabulation. That's very, very important. And then you will be getting the chi-square significance value. So whether you are performing through any software or if you're even performing through the online software, like online applications like Wolfram Alpha, you will be getting the same output. You will be getting the cross tabulation along with the chi-square statistics. So these are the two values. So let me copy paste. So I have applied for even the diagrammatic representation, but so this is the output I have received. So obviously, for chi-square, you will be having observed reading versus expected reading. But I don't want to go on with the expected reading just because the observed reading is very important. And the most important thing is that when you perform chi-square statistics, you need to make sure that all the observed reading values has the value greater than 0.5 in all the cells, most of the cells. And the most important thing is that here, if you see, one cell, that is 6.3% have the expected count less than the value. That is, there is one cell that is, you see this one particular cell is having the value less than 5. So that is not a problem. See, if the value is less than, if more than 20% of the cell, more than 20% of the cell is having the value great, more than 20% of the cell is having the value less than 5, at that point of time, your chi-square becomes useless. You are not supposed to perform chi-square statistics. You have to stop with only cross-tabulation and write the interpretation. And I hope this cross-tabulation is very well explained. That is, with respect to male, out of 340 male, majority of them get the will understand the effectiveness of the provided training using written feedback received from the trainer. Whereas in the female, it is little bit contradictory. They say that they will get verbal feedback from the participants instead of the trainer. Yeah, here also 24 followed by, yeah, both say, male and female say they used to get the verbal feedback from the participants, followed by the second highest is written feedback from the trainer. No, post-training exams. And yeah, you see, it's almost 232. So which means for male, majority of them are telling that they provide an exam, and from the exam they will understand whether the training was effective or not. Whereas for female, it is verbal feedback. It was verbal feedback. So here, if you take a close look, the opinions were different, right? Here for male and female. For male, it is post-training exams, whereas for female, it is the verbal feedback from the participants. So here the opinion is different. That is, there is no significant association between the opinion of the male and female for the to measure the effectiveness of the training program. So that's how you have to write the interpretation. So for writing a chi-square statistics, write an introduction. That is, here the analysis was performed to identify the opinion of the here the analysis was carried out. They assess the effectiveness of the training program done by various genders. So that should be your introduction. In a hypothesis, you have to write that there is no significant association between the male and female in assessing the effectiveness of the training program. So that should be your null hypothesis. It's not is there is no significant association. And here, if you take a close look, the significance value is less than 0.05. So this is what you have to understand very importantly. The thing is that if your significance value is less than, let me write it here. So if it is less than 0.05, reject the null hypothesis. If it is greater than 0.05, accept the null hypothesis. So if you take a close look here, the value is 0.00, which means the value is, this is not only in the case of chi-square test, even for ANOVA, even for independent sample t-test, even for correlation, even for regression, for everything, you have to look at the significance value. That whether you are using the SPSS or AMOS or eViews or any online softwares, you will be getting the same table. The table will have a significance value, and you have to look at the significance value to get make an interpretation. So you see here, it is less than 0.05, which means the null hypothesis is rejected, which means we can say there is significant association between the male and the female opinion. Let us take a close look here. The first opinion is different, but you see the second opinion, the second value is same. the second value, the second highest value remains same for the male and female. And let us even look at the third value. The third value is, with respect to this, is this one. And let me look at the first three values here. This one, and this one. Let me look at this one. You see, if you look closely, very closely, for this particular population, and this 340 as a population, the opinions almost resembles in value. So we can say that there is significant association between male and female opinion in measuring the effectiveness of the training. But more, if we take a close look at the cross tabulation, we can say that male predominantly prefers post-training exams, whereas female predominantly prefers verbal feedback from the participants. We can say that the post-training programs and verbal feedback from the participant, whereas female prefer predominantly the verbal feedback participants, followed by the supervision by the senior employee during the training program. So these two we can say these two, the second option is almost common for both of them. So that's why we are getting the value 0.000. So see, when it comes to chi-square, not just chi-square, if the significance value is less than 0.05, you have to, it is understood that your null hypothesis is rejected. If null hypothesis is rejected, what is the alternative hypothesis? There is significant association between the male and female opinion with respect to the measurement of effectiveness of the training program. So this is how we have to measure or interpret the chi-square test. So first you have to write the introduction, followed by the hypothesis stating there is no significant association between the male and female in measuring the effectiveness of the training program. Then you have to look at the chi-square statistics, the significance value, and then you have to write that the estimated you have to, in the interpretation you have to write the estimated significance value is less than 0.05, which means the null hypothesis is accepted. Sorry, null hypothesis is rejected, which means there is significant association between male and female in measuring the effectiveness of the training program provided in the organization. That's how you have to write the interpretation. So now let me move on to how to write an interpretation for correlation analysis. So I have a separate set of data here. Actually, it is related to training provided performance graph. I have conglomerated all the values and I made this value. So let me perform the correlation for performance gap and organization analysis. So in order to do correlation analysis, go to analyze, correlate. Let me do correlation for these factors, important factors, performance gap, task and job analysis, personal analysis. Okay, let me do for all these things. Great. So I told you, right, you have to look at this significance value. You see, this is the significance value. The significance value is 0.000, which means what is the null hypothesis here? I told you, right, for correlation analysis, both the data has to be metric. If you take a close look here, both the data are metric. So both the data are metric. That is, the relationship, the performance gap, the organization analysis, everything is a metric data. Let me show you. You see all these values, the performance gap, organization, everything is a metric data, numerical value. So in order to perform, I have performed both the data are metric. So I have performed correlation analysis. So in correlation analysis, also you have to look at the significance value. As I stated before, if the value is less than 0.05, what is the null hypothesis here? The null hypothesis is there is no significant relationship between performance gap and organization analysis. There is no significant relationship between performance gap and task job analysis. There is no significant relationship between performance gap and personal analysis. This is what is my hypothesis. So, but here the significance value is less than 0.05. If it is less than 0.05, you have to reject the null hypothesis. Then what is my alternative hypothesis? Yes, there is significant relationship between the performance gap and the organization analysis. There is significant relationship between the performance gap and task job analysis. If there is significant relationship between the personal analysis and performance gap. If there is performance gap, the organization analysis will be predominantly performed. If there is performance gap among the employees in the organization, task job analysis will be done. If there is performance gap, personal analysis will be done in the organization. If there is performance gap, performance discrepancies will happen. If there is performance gap, obviously training need analysis will happen. So this is what is the interpretation. So in order to write, so in interpretation, we can write that there is significant relationship between the performance gap and the organization analysis, task job, personal performance discrepancy, and training need analysis. We can simply write it like that. And how much relationship, in order to know how much relationship, you have to look at the Pearson correlation value. Only if there is significant relationship, you have to look at the Pearson correlation value. So if the value is greater than 0.9, we can say that they are strongly correlated. It could be positive or negative. I told you, right? It could be positive. Relationship could be positive or negative. So here everything is positively related. So it has 81.6% relationship. The performance gap has 81.6% relationship. 0.816 represent 81.6% relationship. So similarly for task and job analysis, it has 79.8% relationship, and it moves on. So this is how you have to make the interpretation. So the performance gap has a strong positive relationship between the organization analysis, performance discrepancies, and training need analysis. It has positive relationship because the value is less than 0.8 but greater than 0.7. We can say that the positive relationship between task job analysis and person analysis. And if it is below 0.6, we have to say weak positive relationship. We have to say as weak positive relationship. So if it is negative, we have to say as weak negative relationship, or weak, negative relationship, or strong negative relationship. That's how you have to write the correlation research. So that's how you have to write the interpretation. So now let me explain you how to how to interpret regression analysis. So for regression analysis, let me do the same thing. Let me consider training.
Sir, I have a doubt, sir.
Yeah, please, ma.
If it is, if you say like if it is 0.5 or 4, but it is positively correlated, but if it is 2 or 3 or 4, it is positively correlated and it is weak. Whether it could be considered like there is a relationship. How do you explain this, sir? I have two questions. This is my first question.
I got it, ma. The thing is that, let me clarify your question. The thing is that in case if the value is 0.2 or 0.3, how do we write? We could write as weak positive relationship or weak negative relationship. That's what is your question, right?
Yes.
I tell you, ma, when it's 0.2 or 0.3 or 0.4, mostly you look at the significance value. If mostly the significance value will be greater than 0.05. If it is greater than 0.05, you cannot consider this above value because they don't have relationship. But in case if the significance value is less than 0.05 and the value was something as what you said, it's between 0.2 or 0.3 or 0.4, you have to say as they are weak positive relationship between these two factors. That's how you have to write. But the first and foremost, you have to look at the significance of it, because if it is
sometimes when I'm also as a faculty working in a college and doing my SPSS for the PG students, sir. Okay. The SPSS version what I have, I set as 0.01 for correlation alone, bringing it as a 99% of thing and 1% of because default it is in my version it is default 0.01, and most probably when it is positively correlated, the significant values always falls as 0.000. Most probably. That I don't know whether it is correct. I just want to clarify that also.
No, ma.
Because you say
you have made a wrong settings, I think so. The thing is that if it is if you have considered 99% as a confidence interval. 99 as a confidence interval. Obviously, most of the time, the significance value will not get 0.000. Either the data, what you consider as a very strong relationship, only at that point of time, you will be getting 0.000. But in case in 99% confidence interval, you won't be getting the significance value. Please
Okay.
check the settings, ma.
Okay.
Go to the file option, go to the edit option.
Okay.
There is something called as options. In the options, when you click, it will be giving you various settings output in the thing. Just clarify whether you have right settings or here, because I cannot explain this in this session. But if time
Okay.
permits, in the SPSS class, I'm going to take that there I will let you know. Okay. So
And
the thing is that first look at the significance value. If it is less than 0.05, you can say that there is relationship. And after that, you have to say, look at the Pearson correlation value. At that point of time, you have to look at whether they are having less than 0.5 to say weak positive or weak negative relationship, or it is between 0.5 to 0.7 to 0.8 to say there is positive or negative relationship, or it is having more than 0.8 to say whether they have strong positive or strong negative relationship. So now you got me, Ma.
Yes, one more question I have. You have already said this as variables and you're correlating with the variables, sir. When we set the question from the base, I'm asking.
Ma, this is not variables, Ma. These are factors.
Okay.
For your information.
Factors. Sorry, these are factors. Okay, when we set the questioner, if there is a negative question in that questioner, okay, then how do we interpret this correlation, sir? For example, online shopping behavior, payment options, when we consumer behavior patterns.
Negative value, ma. You will be getting negative value. Say, for example, you have consumer behavior towards e-commerce advertisement. Obviously, nobody likes advertisement to pop up in their e-commerce platform.
Okay.
So they have negative behavior. But if that is one of your factor, what happens is that they will be giving a negative values. They will be getting this consumer behavior towards e-commerce platform will be different. Will be having a positive values. But advertisement, e-commerce pop-up advertisements, you will be getting negative values. So what happens is that it will be negatively correlated. You will be getting negative values. Instead of positive correlation, you will be getting negative correlation. But the most important thing, if it has relationship, you will be getting negative relationship. That's how it will be, ma.
Okay, understood, sir. Thank you so much. Thank you so much.
Okay, ma. Okay. So now let's move on to the regression analysis. So where have I left? Yeah, regression. So let me consider training need analysis as one of the dependent variable, because that's the major importance of the study. And performance gap, performance gap, performance discrepancies as independent variables. So let me click OK. So here I wanted to know whether the performance gap and performance discrepancies in the organization creates an opportunity to provide training need analysis or impact training need analysis. So here, in order to interpret regression, you have to look at the many values. Let me put it in Excel sheet so that you can clearly able to view and understand. Yeah. Yeah. Okay. I don't know what is happening here. Yeah, now I got it right. Okay. When it comes to regression, you have to look at many values. The first and foremost is these two values, followed by these value, this particular value, and these particular values. Regression is a beautiful analysis for prediction, ma. You can predict the future using regression analysis. If I wanted to explain, it will go for hours. But this is the thing. So I will tell you how to interpret first. Regression analysis is nothing but to understand the impact or influence of one variable on the another variable. So what is here? I wanted to know whether the performance gap and the performance discrepancies together impact the training need analysis. So this is what is my hypothesis. There is no significant impact of performance gap and performance discrepancies on training need analysis. This is my hypothesis. So to test my hypothesis, I have made regression analysis. In regression analysis, first you have to look at R value. The R value and R square values are very important. The R square value should be greater than 0.6. Let me repeat once again. The R square value should be greater than 0.6. The R square represents the forecasting accuracy. So here it is greater than 0.6. It is 0.793. So we can say that our forecasting power of this regression equation is 79.3%, which is acceptable, and it is having the value greater than 0.6. And the most important value, the next second important value is the ANOVA significance value. The ANOVA significance value should be less than 0.05. It should be less than 0.05. Only then we can say that our model is fit. Say, for example, if you are performing SEM or path analysis, we will check whether our model is fit using the model estimates. Similarly, if you are performing regression with 2 or 3 factors, we have to check whether our model is fit. So in order to tell that, the ANOVA significance value is used. If the ANOVA significance value is less than 0.05, your model is fit. And then only you have to look at the coefficient significance value. Everywhere you have to look at the significance value. Whether the output is produced through SPSS or PSPP or AMOS or eViews or any software for the medium, even if you do analysis, here if you data analysis solver. You can perform histogram, regression analysis, correlation analysis. Everything will produce the same output only. Same output only. Yeah. Here also the coefficient significance value should be less than 0.05. Only then we can say that this particular factor influence this dependent factor. And if this value is also the second factor value, coefficient significance value is also less than 0.05, we can say that yes, performance discrepancy also impact the training need analysis. In case if this value is greater than 0.05, we could only say that yes, only performance gap impact the training need analysis, whereas the performance discrepancies does not impact the training need analysis. But here in this case, both the values are less than 0.05. So we can say that yes, performance gap and performance discrepancies together impact the training need analysis. So we can say that the factors, the performance gap and performance discrepancy and training need analysis, all three together have a relationship of 89.1%. And the regression equation forecasting accuracy is 79.3%, which is more than acceptable value. Our model is fit. It is less than 0.05. And both these factors impact the training need analysis. So this is how we have to write the interpretation. So what is our hypothesis? There is no impact of performance discrepancies and performance gap on training need analysis. So what is our interpretation? Since both the coefficient significance value is less than 0.05, the performance gap and performance discrepancies impact the training need analysis. So this is how we have to write the interpretation. And you can also go for y equal to a plus bx formula to predict. So in order to predict that, see, I tell you what, there are various kind of regressions. Linear regression is just a part of it. You go to regression, you go to curve estimation, you see, apart from linear regression, there are quadratic, compound, growth, logarithmic, cubic, sine, exponential, inverse, power, logistics. There are so many type of regression. And the linear regression equation formula is what we know mostly. That is y equal to a plus bx. That is a and b are constant. A is nothing but this beta coefficient value. That is b. Here there are two factors, right? So b1 x1 plus b2 x2. That is B1 is nothing but this value into X1 is nothing but the performance gap. Similarly, B2 is nothing but 0.562 into X2 is nothing but this value. This is something a social science studies data, but if it is a secondary data, you can make a forecast. So that if time permits, I will let you know, Ma. Okay. So today we have discussed about how to perform and how to interpret a simple percentage analysis, descriptive statistics, under what circumstances you need to use chi-square test and how to interpret a chi-square test, how under what circumstances you use correlation analysis and how to interpret the correlation analysis, under what circumstances you use regression analysis. So all these we have discussed. And during the next class, I will be talking about the significant difference test, and I will be talking about the ways to publish article or write the things thesis more effectively. Okay, so I think this is more enough for today's session. I don't want to dump everything in today's session. So tomorrow we will discuss about this significant difference test. That is one categorical data. Various criteria to select this independent sample t test or ANOVA, one way ANOVA, paired sample t test, followed by the other topics. So is today's session everything clear, man? Do you have any doubts? Yeah, you can unmute and ask me, ma. Is everything clear in today's session? Do you have any doubts, ma? So anyone, any doubts?
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.